Alright, now that we've learned how to find net force acting on a system of charges, it's time to start figuring out how we can put charges into equilibrium. Looking at our drawing here, force 1, 3, and 2. I put 3 in the middle because I believe, at least the old version of the book used to put 3 in the middle. If we don't know these distances, it's hard to tell where we can put number 3 here so that it will be in a system of equilibrium. So now that we know the individual forces, we need to recognize that this system is not in equilibrium. The force between charge 1 and 3 will be much greater than the force between charge 3 and 2. So what are we going to do? For the system to be in equilibrium, we're going to move charge 3 probably over this way and set force 1, 3 and force 3, 2 equal. So how do we do that? When you're going through these steps, go ahead, pause it, write down the steps, and take your time. So let's start. Step 1. Set the forces equal to each other. So you're going to write down force 1, 3 equals force 3, 2. So the force represented by this line will equal the force represented by that line. Go ahead, pause, and write this down. Alright, now you're ready for step 2. Substitute the equations in. So Coulomb's constant times charge 1 times charge 3, because we're doing 1, 3, over distance 1, 3 is squared. This is distance 1, 3. Then Coulomb's constant times charge 3 times charge 2 over distance 3, 2 squared. Distance 3, 2 is this distance here. Go ahead, pause it. Alright, now you got that written down. If the total distance is 3 meters, use substitutions kind of like you do in algebra class to solve for each d and then plug it into the equation. So what do I mean there? If the whole distance is 3 meters, distance, say, 3, 2 is equal to 3 meters minus distance 3, 1. Right there. You know, distance 3, 1, and then the rest would be called 3 meters minus distance 3, 1. See how that works? If I throw example numbers in, if distance 3, 1 would end up being 2 meters, that would mean that 3 meters minus d1, 3, which is 2, is equal to 1. So 2 and 1 makes the 3. So we're going to take these numbers and, plug them up into here. We're substituting this in for d3, 2. Okay? Go ahead, pause it if you need to comprehend that. I can't grab that, I don't care. Now what we need to do is cancel out some like terms. Let's make our math easier by getting rid of things we don't like. So if I pull that out, check it out. Coulomb's constant is the same on both sides, so we can get rid of that. Charge 3 is the same on both sides. So what we'll learn is, doing these problems, the middle charge, the size of it just doesn't matter, and that makes our math so much easier, because then that leaves us insert the charges and solve. That leaves us with 9 times 10 to the negative 4th over d squared equals 4e to the 4th times 3 minus d squared. There's even a trick. Here's this little asterisk. If you look in the sample problem, if these exponents are the same, if you are comfortable with doing this, you can cancel even the exponents. Now, if that makes you nervous, if that makes you uncomfortable, don't do it. Keep them in there. But now, if you really look at it, it's 9 over d squared is equal to 4 over 3 minus d squared. That seems to me to be something very, very solvable for you. So in solving that, you're either, did I do that on the next page? No, I didn't do that on the next page. In solving that, all you're going to do is cross multiply. And you can cross multiply first or square root first. That's totally up to you, however you want to do that. But you're going to cross multiply, so you'll bring this term up to here, bring that term over to there, and then because you got these squareds, you'll square root And that will leave you on this side, because the d's over here, once you square root it, you'll have 2d. And over here, you'll have 3 minus d times 3, because you square rooted everything. Well, that's extremely easy for you guys to solve those. You are smart enough to do that. You solve for your d, and then once you have your d, let's say it comes out to nice easy 2 meters. You would plug in your 2 meters here, and you put in your you put your 2 meters in there, and you find this is 2 meters and that's 1 meter. And those are 100% example numbers. I don't know if that's right or not. Okay, so take this these ideas and look at the homework here on page 560. Do 1 and 2, and take your time. Write out all your steps. Okay, take your time, and you can do it.